Hello, my name is Sean Aurora, and I have the honor of being the keynote for um, your conference. I want to first of all make sure that we are live and that uh, I'm speaking to the audience. Great. Okay. So my name is Sean Aurora, and I am the director of the Kendeda Building for Innovative Sustainable Design at Georgia Tech. I am not somebody who is in your particular field. I'm not in the IT field. I'm not a designer. I'm not an architect. I am someone who talks about um, why we have buildings and how buildings impact our lives and how we can do better when it comes to buildings. So, with that, we're going to start with a short video that asks, what are buildings for? We think that buildings are made for people. But if they're made for people, why are so many of our buildings causing negative outcomes? Flooding. We have just waste and pollution and depletion of natural resources to create those buildings. So many of our buildings create unhealthy environments outdoors and indoors. So there's got to be a better way. We ask and have shown that there can be a system, a way of thinking that results in buildings that are better for humans and for the environment. So while you might be thinking, why is the keynote about one particular building? It's really not about one building. What we're going to talk about today is that system of thinking. It's that way of asking ourselves in everything that we do, what does good look like? And the genesis of the Living Building Challenge was just that question. We have lots of green building standards in the world. Everyone's heard of LEED. Some architects asked that, what if these green building standards was just a way of creating a status quo that is slightly better, rather creating a future that's slightly better than the status quo that we had. So they asked the question that if we were able to start completely from scratch, what would good look like? And it's that question that resulted in this idea called the Living Building Challenge. All right, the Living Building Challenge is essentially a recognition that we cannot have sustainability be the goal anymore, because what we're sustaining is an environment that's very degraded. Our relationship with the environment is very much we take, and we give back pollution and waste. Increasingly, buildings are where we spend more than 90% of our time. Before the COVID pandemic, it was estimated we spent 90% of our time indoors. And since COVID, we know that some folks were spending 100% of their time indoors. So the idea of what buildings are doing to our health, to our happiness, has been elevated, I would say, even more so in the last couple of years. So if we are spending so much time in buildings, and if buildings are indeed our most lasting creation, is it enough to be sustainable? And the answer that the folks who came up with the Living Building Challenge was no. It's not enough to be sustainable. We, in fact, need to be regenerative. And so what that means is we give back more to nature than we take. We are net positive in energy. We are net positive with water. We are net positive when it comes to the lack of construction waste. And we put a lot of emphasis on people. And so looking across nature, the folks who came up with the Living Building Challenge found a natural metaphor for what it is that they were thinking of doing. And that natural metaphor was a flower. So we want buildings to be like flowers. Living buildings, they are designed to give back more than they take. And a flower gives back more than it takes, because everything a flower needs, it gets from its site. And when the flower leaves, there's no record, there's virtually no evidence in the fossil record that a flower was ever here, but we know it was here because it gave more to us than it took. It gave seeds, it gave life. So we want flowers to be the metaphor, and like the petal of a flower, the Living Building Challenge calls its performance areas petals. That's really what they are, they're petals. And there's 7 petals. 7 petals are place, water, energy, health and happiness, materials, equity, and beauty. And so those are the 7 conceptual performance areas of the Living Building Challenge. And from conceptual, we go to the more detailed. And we'll get into some of that in a minute. Those detailed items are called they're requirements called imperatives. So there's 7 petals, and in those 7 petals there's 20 imperatives, and across those 20 imperatives there's like 600 things that you have to do. You have to do them, and the reason you have to do them is because we're going back to our flower metaphor. All right, so what happens to a flower when you pull the petals? It falls apart. And so what we're trying to do by requiring all 600 something that have to be done is you are forcing innovation. All right, you are forcing folks to say, I don't have a way out of this. I got to do it all. And if you got to do it all, you got to innovate. And that's why it's called a challenge, my friends. There are only 28 fully certified living buildings in the world. Only 28. And the reason is, this is hard. This is very hard. So why do it? Why do it in the first place? Well, you do it to prove that it can be done, and to show other folks the way that it can be done. So we're the 28th in the world, right over here, Georgia Tech. But we're the first in our region at the scale. And that was very important. The Kendeda building exists because of a very generous gift from the Kendeda Fund, hence the name. They gave $25 million for the design and construction of this building, because most fully certified living buildings are in the Pacific Northwest, the Northeast, parts of the country with very different climates. And, you know, as long as the example of a net positive building is in Seattle, Portland, or Massachusetts, you're not going to get a lot of traction with the design build community here in the hot, swampy Southeast. So we had to build it here to show that it could be done, and we've done it. All right. Unlike other green building certification standards, it's not enough to take all the paperwork, submit it, folks review the paperwork, and you're like, okay, you got to prove performance. You got to prove that you're net positive energy. You got to prove that you're net positive water over the course of 12 months, what's called the performance period. And we did it. So we are fully certified. Yay. Now step back and say, well, what is this building? This building is a 37,000 square foot indoor, plus another 10,000 square foot outdoor, multidisciplinary teaching space. And what we mean by multidisciplinary, hi, there's me. And what we're doing right now, folks, is actually we're on Google Street View. You could go on Google right now and do what I'm doing. But this is a multidisciplinary classroom. Over here in the design studio, we'll have a lot of architecture classes. Over here on my right and on your right, there's a teaching lab. We have a small seminar room right there where we have classes. Up here, we've got 2 60-person classrooms, and then we've got a really large really large auditorium over there, 170 people. We got some offices. This is where I sit, along with the Office of Campus Sustainability and our Global Change program. And the idea is we get all of these different perspectives, students who are physicists, who are engineers, architects, biology majors, chemistry majors. They're going to come through this building, hopefully see the sustainability, the regenerative features of this building. They'll get inspired, and over here in the common areas, they will start having the conversations. They will cross-pollinate, to go back to our flower metaphor. Their ideas will become the seeds. The seeds are the solutions of the problems that we have, problems of our relationship with the planet, our relationship with each other. So that's what the building is. Okay, why it is to prove that it can be done. That's why it is. We like to say it's a Southern solution, built by Southerners for Southerners. We have a different climatic environment down here. We've shown that we can overcome that different climatic environment. We have a different economic environment down here. That's namely utilities. Our utility structures, our electric utility structures, completely different than other parts of the country. And we have a different cultural environment down here. So, when you talk about what it is that you're doing in this building, you lead with different stories first, because at the end of the day, no one really is wanting the decimation of natural resources. I like to joke that everyone ultimately is a tree hugger. No one really sits around wishing for the complete destruction of all trees. There might be one tree in your neighbor's yard or your yard that's giving you consternation, but we all recognize the importance of trees. All right. So with that, what I'm going to do right now is just do a quick run through of some of the stuff we did to get to net positive. And I'm going to try to make it relevant to you and in your profession, because increasingly buildings like this are going to require a detailed integration of IT, of systems, of Wi-Fi networks. You're going to learn more about that tomorrow when my colleagues speak to some of the innovative things that we did. But y'all are going to be part of this future. It's going to be something that's increasingly going to be done by folks who are on sort of your end of the project team. So we thought it would be really important for you to understand some of the philosophical things, the reasons why we're doing what we're doing, and also how we got there. And so as you listen to this, I want you to think about where and what it is that you do on a daily basis, and how your expertise could come and help move this type of regenerative approach forward. So we are now going to go back outside, because the first pedal is place. And that should be obvious, because a building that doesn't stay in one place is an RV. It's not a building. So buildings really should be designed for place. I once had an architect tell me that we as in the building community lost our way when central heating and cooling came about, because we stopped thinking about designing for place. So this place used to be a parking lot, not unlike what you see across the street, and now it is this beautiful building. But it's more than just this beautiful building, it's also all the landscaping that is around the building. And while it just looks like beautiful landscaping that might not have had much thought, it's very much designed for place. And where we are in the Southeast, we get a lot of rain. I mean, a lot of rain. And most places aren't designed to accommodate that rain. In fact, most places are designed to think of rain as an afterthought. So take this road, for example. This road is doing its job very well, and its job is to transport um, vehicles. We've retrofitted bike lanes, so the bike lane is uh, providing safety for bicyclists. We've got this nice wide sidewalk. This asphalt, this concrete, bricks, they're doing their job. But what are they doing to stop rainfall from becoming stormwater? The answer is nothing. There is a connection right here where the road meets the drain, and the poor folks that designed the drains, that's it. That's their connection. What type of integrated approach did these two pieces of infrastructure have? Probably none. That's it. It's the drain. And now the team that has to design the drains and maintain the drains, that stormwater is their problem. And they just accept that as their lot in life, that stormwater is going to happen and stormwater is their problem. We, the taxpayer, have accepted that single-use infrastructure is the norm. This road is doing one thing, the storm drains are doing another thing. Single-use infrastructure, that's the norm. In our region, this single-use infrastructure breaks. It breaks all the time. We are getting so much rain and we have so much impervious surface that sewer system is getting inundated with stormwater. Just last week, the county in which I live had another 1-million-gallon sewage spill. We just accept this. Single-use infrastructure, that's the norm. Well, that's really not the only option we have. Because again, right now, the rain just goes straight into the drain, onto the wastewater treatment plant, as opposed to our site. In our site, we've designed the whole site to manage rain by having it go into the ground. These bioswales take the water into the ground. The pervious pavers take the water into the ground, and our rooftop canopy and ceiling, roof, collect 40% of the rain and channel it to an underground cistern, 50,000-gallon cistern. So this entire site is designed to be like the Piedmont forest, which is the natural ecosystem of our region. 90% of an average rainfall stays on site. So this building is not burdening an already overburdened infrastructure. It's managing its rainfall on site. We use the water in our cistern for drinking water. We have a rainwater drinking water system that once it's activated will allow us to go completely off the water grid. We will be our own municipal water treatment system. We will be drinking the water that would normally go into the sewer. These over here are called bioswales. They help store the water. The pervious pavers let the water seep through. The pervious concrete lets the water seep through. And we've got a beautiful, lush amenity as a result. What does this have to do with y'all? It is about systems thinking. It's a systems approach, right? If we have single-use infrastructure, it doesn't matter what kind of infrastructure it is, single-use physical infrastructure, single-use information technology infrastructure, if we don't think about how to integrate disparate pieces of a building so they're working more in harmony to get to good, to get to better, to get to less burdensome to the building owner, to the taxpayer, then we're missing opportunities. It takes longer on the design side, but on the construction side, the post-construction side, the operations and maintenance side, you can have tremendous advantages. And I'll tell you right now that most users are probably going to like the outcome better. We're going to spend a lot of time on water because water is not only the second pedal, but water is life. We've spoken about rainfall, the water that goes into the sink and the shower drain, in the Kendeda building, all that water is treated right here in a constructed wetland. So we're using natural systems to treat that water and get it to a level where we can release it into the ground, where then, just like a forest, the ground is going to filter that water further until that groundwater hits a creek, a stream, and ultimately into one of our region's primary rivers. Another type of water is the water that you collect from an HVAC system. Our building does not, our building does not have a conventional HVAC system. Those are very energy intensive. What we have is, now we're at the roof. We have now magically transported ourselves to the roof of the building. What we have is a dedicated, and now I'm inside, sorry. We have a dedicated outdoor air system. And what that does is it takes cold, stale air from the inside, pushes it outside, brings in hot, humid air in the summer from the outside. Using the law of thermodynamics, there's an energy wheel inside. You know, cold air sinks. And so we are using that cold air from the inside to lower the temperature of the hot, humid air. Then we're stripping that hot, humid air of humidity, because it's humidity that really makes us uncomfortable. How many of us have been in a conference room? If this was live right now, we'd be in a conference room somewhere, and we would all probably be extremely cold. We would be freezing in the middle of summer because we use air conditioning for cooling. We use air conditioning for dehumidification. Here, what we really are using for dehumidification is a dehumidifier. So obviously, we're going to have lots of condensate. Boom. We do not waste that condensate. And then perhaps what gets the most attention, I am now on the second floor of the building, is our composting toilets. Instead of going to the bathroom and drinking water, we go to the bathroom in a toilet that has foam activated flush, uses about a teaspoon of water per foam. You do your business in the building and you leave. Your business stays in the building. We're going to now go straight to the basement. Your poo and pee ends up in one of these 6 bins. There's 3 bins on the other side as well, where natural systems decompose your biosolids, your liquid, and ultimately what we have left is 2,000 gallons of compost tea. It takes about 4 to 6 weeks to fill up these 2,000 gallons. The solids are going to take years, a decade or more. And what we have, folks, is a system that doesn't connect to the sewer at all. Does not connect to the sewer. So from a water perspective, by the end of this month, hopefully, we will be a fully certified municipal water treatment system. That means when you turn on your tap, anywhere you are, there's a municipal water system that's providing you that potable water. We will be our own municipal water system. So we're going to take the rain that falls on our site, we're going to purify that to drinking standards, and we're going to use that purified water for everything. Once it's used for hand washing and for showers, our constructed wetland up front is going to take care of purifying it, and then it'll go into the ground soil. Once you use it for flushing, rather foaming a toilet, your bio waste will stay here. The building does not connect to the sewer from a bio waste perspective. It's a closed loop, right? That is not single-use infrastructure. That is multiple-use infrastructure. On the energy side, it's pretty simple and straightforward. No matter where you are in the world, the basic techniques are the same. You want to, now I'm at the second floor of the building, because I want y'all to see the various pieces of how to get to net positive energy, you construct a very efficient building. This building is about 3 times more efficient than code. We have triple pane glass, lots of insulation. We have very efficient mechanical systems. I've already shown you the systems that we have for the dedicated outdoor air system. There's other things that we're doing to dramatically reduce the amount of energy that would be consumed by electrical systems. Then we have a 330 kilowatt rooftop solar power station, which these pieces combined resulted in the building producing 225% of the energy it needed during its 12-month performance period. Or to put another way, the building produced enough electricity for itself, its twin that doesn't have on-site solar, and still had 25% left over for the rest of the campus. Our goal was 105%. We got to 225%. So if we wanted to prove you can build a net positive building in the hot, swampy South, we proved it 2 times over. And there was a time when I thought, man, we totally over-designed the energy system. We didn't have to spend $1 million on the solar canopy. But I very quickly changed my tune, because what we in fact have done is created a building and solar system which combined will still be net positive 30 years from now. So as modeled and as we are currently performing, we will be net positive 30 years from now. And so when you take into account the net positive solar and energy efficiency system, when you take into account that we've shown how you can have a closed loop water and sewer system, what we've really designed is a resilience hub, a building that is able to withstand severe climatic disruptions that we're seeing happen all over the world. Most recently, the extreme flooding that's happened in China, India, and Europe, the extreme heat and drought in the West, and then let's not forget the just completely unbelievable winter events that we had in Texas over the summer. So this building, it really serves as a template for how communities can create hubs of resilience during these times of extreme climactic pressure. There's a lot more that we can talk about, but I'm only going to talk about sort of one more thing and then one parting idea before we open it up to a limited amount of Q&A, because I don't want this to be just me yapping all the time. The third type of net positive we have to be. So we're net positive energy, net positive water. Last year, we collected and infiltrated, I think, 15 times more water than we used, 15, 16 times. The other type of net positive that we have to be is materials. So waste during the construction process. So during the construction process, we sent less than 1% of the construction waste to the landfill. That's important because up to 50%, 40 to 50% of construction waste, 40 to 50% of landfill waste is just construction and demolition debris. We've all seen it. We've seen just giant trailer just full of construction and demolition debris that gets thrown away. So not only does this building divert over 99% of its construction and waste debris from the landfill, we incorporated salvage materials. So what you see here is wood taken from Georgia Tech Tower. This building is the second oldest building on campus, the oldest remaining building on campus, built in the 1880s. So these longleaf pine trees began their life in the late 1700s, early 1800s. They were felled in the late 1880s to make Georgia Tech Tower. And when that iconic building had to be retrofitted, instead of throwing away these beautiful pieces of wood, we repurposed them into these stairs. and thereby extending their life, preserving a piece of Georgia Tech's history, and saving $60,000 in the process. And that's 60,000 in 2017, 2018 dollars. We know how much the price of wood has gone up. These are trees that fell down of natural causes on campus that we repurposed into, I'm on the second floor now, that we repurposed into our live edge countertops. That far wall on the exterior, on the other side, as well as this ramp, that is salvaged wood that came from a building that had to be torn down and make way for Georgia Tech's new police station. So, what we've learned is folks inherently understand that we shouldn't be throwing things away. Right? They know that we could be doing better. And when they see the beautiful materials that we've salvaged, they start thinking, okay, this is again a single-use infrastructure moment where we've designed the system to fail. Our system does not have a way of capturing and storing what is otherwise a perfectly amazing source of building material. And Georgia Tech has incorporated this concepts of salvaging materials and reusing them in other buildings and other projects, but admittedly right now it is rather limited, in part because there isn't a normalized supply chain for these items. And one of the things that we really hope happen is that there's a growing trend and a growing demand for 100% salvaged material, like the bricks that we have in the building. They are 100% salvaged material aggregate. So you see the brick on that far wall over there, 100% salvaged material. And so, yeah, just, remember, there's a better way. The last thing I want to say is, again, going back to, I think, how we all need to do our work now, is that if you've got 600 things that you have to do, every one thing that you do better satisfy 3, 4, 5, or 6 of those requirements. Okay. So I'm going to give you an example of one thing that we did that satisfied so many requirements, and that's the ceiling. I'm going to count them down. This ceiling is beautiful. Now, beauty is in the eye of the beholder, but in the beauty pedal, right there, that's the beauty pedal, we have an imperative, that's the second tier, called education. So not only is the ceiling beautiful, but it's a type of construction called nail laminated timber. Okay, and that's a 2x6 and a 2x4 nailed together to create about 500 panels, and then plop. Why is that important from an education perspective? Is because we want, so that's one thing, by the way, beauty. We want to encourage the use of mass timber in commercial construction. So here we have nail laminated timber, and here we have glue laminated timber. The reason we want to use mass timber in construction, because timber stores carbon, stores atmospheric carbon. So we are replacing the need for concrete and steel beams, and that reduces the carbon pollution of the building day one. That's two things, all right? Reduction of carbon pollution. But then this wood is local. It's either from Alabama or Louisiana or Georgia. And that satisfies another requirement that 50% of everything in this building has to be 1,000 kilometers or closer sourced. It's about 600 and something miles. All right, that's another requirement. The trees were sustainably harvested because we don't want clear cutting of natural forests. So that's four requirements. The wood that was sourced from Georgia is actually salvaged wood. It was salvaged from Atlanta's film industry, from the film production of the show 24 and the movie Rampage. So we're furthering the net positive waste requirement. And then these 2x6s, they were too long, and we had to cut the ends of those 2x6s. But instead of throwing them away, we turned the ends into these stairs. You count them? That's 6 things. But we didn't stop there, because the Kendeda building and the Living Building Challenge is asking us to do more with one idea. So you're constantly thinking, what else can I do? What else can I do? What else can I do? So we started thinking about equity in the built environment. And what we realized was very few of the workers who work at Georgia Tech are from some of the lowest income communities that border our campus. So we reached out to a nonprofit that focuses on helping homeless men get off the street. And one of the ways to do it is through workforce development. The 6 individuals, some of them you can see here, helped us construct that ceiling. And what they got from that was marketable skills that helped them move ahead. So if there are 3 things I want y'all to remember from today, it's the following. 1, do more with one idea. Now, whatever it is that you're doing, always think, what can I do better? How can I create the next best thing? Do more with one idea. 2, single-use infrastructure is no longer an option. So whatever it is that you do, always be thinking about, all right, if I'm doing this one thing, is there a way to make it do more than one thing? Single-use infrastructure is not an option. And the third thing I want you to remember is, hopefully you never forget what you have learned today. Like, once you know that you can build a building better, don't forget it. And that's what we like to think happens with anyone who looks at the Kendeda building or experiences it, that they're just not going to forget this. And they are going to take these things with them and be the change agents in their communities. So with that, thank you so much for your time. And I see there's some questions that have already come into the chat. So let's see. Was campus facilities involved in the process for conception of operations, and was specific training created for them to manage this very unique facility? So portions of campus facilities was involved. There were other portions of campus facilities that were not involved. I'll tell you this, on the operations side, definitely if you're going to design something, have folks who actually know how to operate a building be part of the design process. But with regard to specific training, the one area where most projects require specific training is in the area of continuous green cleaning, because there are certain chemicals that are not allowed to enter the building. Fortunately for us, Georgia Tech has a green cleaning process for the entire campus that complied with the requirements of the Living Building Challenge. So we didn't really have to do much. So to answer your question, no, limited training, but definitely would have had some more of the operational folks from facilities in the design process. Do the systems in this building automatically feed their data to a central? Yes, they automatically feed when they work. Bada bing. But yes, we have a HEPTA system. All that data is fed into the system, and we are able to slice and dice and look at the data in many different ways. Was a cost comparison analysis done? I've never been asked that question. No, not before, because I want to remind folks it was 100% donor funded. We had an amount that we had to stay within, okay, $25 million. So it's not like we had a blank check. We had an amount we had to stay under. But the whole purpose of the building is to be an R&D project, right? We remember when the price of cell phones were so high that only Wall Street folks could afford cell phones. I've got 2 now. One's for personal, one's for work. So, price goes down the more you learn. This is the first building of its scale here in the Southeast. It's been over-engineered. Okay. Um, but we did do a quick side-by-side cost analysis of the Kendeda building and its most closely related building on campus, which is about 10 times as big, but it's also a classroom, auditorium, flexible state space with offices in it. If you take a look at the inflation adjusted cost of that building and the Kendeda building, basically 2018 dollars. The Kendeda building is 13% more expensive. However, you have to keep in mind that it's very difficult to compare a conventional building with a fully certified living building, because a fully certified living building basically is buying electricity up front, right? So in a conventional building, utilities are on the operations side of the ledger. In a living building, the utilities are on the construction side of the ledger. So we've bought 30 years of electricity up front. We basically have bought a rainwater to drinking water system and a sewage treatment system for a 37,000 square foot building. Had that rainwater to drinking water system been for a building 10 times as big, the cost wouldn't have been 10 times as more, and therefore the costs of that system could be spread across more square footage. So in that regard, they're really uncomparable. And one of the things I ask folks uh, on a tour is raise your hand if you think the price of water is going down in the future. No one has ever raised their hand. Then I ask, do you think the price of electricity is going down in the future? I mean, only a handful, less than a dozen have ever raised their hand out of thousands of people that I've asked. So yes, there is an added upfront cost. Is it really 13%? Probably not. We've over-engineered this building, but part of that 13% is utility insurance. Think of it as utility insurance. As the price of grid electricity goes up, our solar system is going to be paying itself off even quicker. As the price of water goes up, it's not going to impact us. We're using rainfall, and it's designed to withstand like the worst drought we've had in 40 years. As sewage fees go up, we don't send anything to the sewer. So this is insurance. The way I think about what we've done here is we've bought insurance against an increase in utilities that we know is coming. All right. So we are going to have more discussion at the unconference session tomorrow afternoon, where my colleagues are going to really dive deeper into some of the IT systems that we have and the unique way that we were able to substantiate this building's performance despite the fact that COVID hit, boom, right in the middle of our performance period, and our building occupancy was obviously impacted as a result. Got 2 more minutes for a question, comment, criticism, critique, observation. All right, well, at this point, I'm going to say, please follow us on social media. We are at, where'd it go? All right, I got too many things open. We're at Kendeda Building across all the platforms. We are on LinkedIn, Twitter, Facebook, Instagram, YouTube, at Kendeda Building. And so said, also doing for fellow humans. Yeah, we are a happy place. One of the things that we have really focused on in the last year and a half because of COVID is the health and happiness pedal. I didn't get a chance to tell you about the red list. The red list is 22 worst in class chemicals and materials that are known to cause harm to humans and the natural environment. This building is probably the cleanest building in the state. We have vetted everything in the building that is permanent, a permanent fixture in the building against the red list. And most of the stuff that you see around you right here, completely red list free. So it's a very healthy building. So yeah, we've definitely designed it for people. We have a beautiful rooftop garden that gives us lots of food and vegetables throughout the year. But yeah, at Kendeda Building across social media. Please follow us. Keep in touch.
Wow. Thanks, Sean. That was excellent. Just loved seeing how you guys are approaching sustainability and innovation with these new buildings. I think there's a lot we can take away with that. Um, I really that was very exciting, very insightful.
Thank you. It takes a village to create a living building.
I'll bet. All right, next we have Matt Orley coming up. He's with Big Paper, and this is a special thing that CFTA is offering for everyone else for this conference. Matt is an illustrator who's going to be illustrating throughout this conference, and he's going to talk to us a little bit about what he's going to be doing for us. So I'll pass it on to you, Matt.
Very good, very good. Thank you, Chris, and thank you, Shane, for sharing about the Kendeda building. Hearing about the pedal and the pedals, excuse me, and the 20 imperatives and the 600 components that you have to meet. There's a lot that goes into this building, and I think I caught maybe 4 of them. I think overall, but I mean, water, your energy, and materials. I mean, I've seen other things about the Kendeda building, and your material use is really amazing. Talking about the 1700, the wood from the 1700s, that says a lot, and that's a lot of fun. So I'm not sure about those foam flush toilets. I'll have to see it before I get involved, but kind of exciting. Anyway, I'll be here for the next several more sessions today, and then tomorrow as well. And I'll be drawing what I hear over the course of the day. So all these drawings are going to be available to the entire attendee list in PDF format, so you can take a look and relook at what was discussed over the course of time. So this is me. I'm Matt Orley, Big Paper Strategy, and thanks for having me, Chris. Back to you.
All right, thanks. You're making us look bad. I think you're learning more than we are, and actually able to draw it at the same time. So I'm quite impressed. So next we have one of our sponsors coming up. Going to do our diamond sponsors have a spot to do short presentations throughout the conference, thanks to the support of all of our sponsors. So first we have Plan On, who is doing Smart Campus 101, apologies, engineering the campus of the future today. So we're going to bounce over to a video on them. At some point.